Hello friends, welcome back to Ekeeda. Until the previous videos, we have discussed different problems based on the theories. Now, let us discuss a problem based on the symptoms parameters. An embankment is being constructed of a soil whose parameters are C dash and phi dash. Let us assume that there is an embankment. It is going to be constructed. Okay. Now, parameters given, C dash is given, phi dash is given, and for the soil gamma value is also given. The pore water pressure determined from the triaxial test. Okay, pore water pressure parameters also given, A value and B value. Find the shear strength of the soil at the base of the embankment just after the fill has raised from 3 meter to the 7 meter. That means, according to the problem, this initially it is of 3 meters, but now it is increased this height from 3 meter to the 7 meter. So what is the height that is increased? 4 meter. So if this embankment is raised from 3 meter to the 7 meter, then what about the shear strength? So in general, how you will find out the shear strength or shear resistance? That is what nothing but a C plus sigma tan phi. If you see the given question, effective cohesion is given and effective internal friction is given. But what we have to find out? We have to find out what is the effective normal stress. Suppose, let us assume that this embankment is of 3 meters. What will be the normal stress? That is what nothing but that will be equal to the whatever the height 3 into whatever the gamma of the soil. Gamma of the soil is nothing but given as 16. That will be equal to 48 kilopascal. So before rising this embankment from 3 meter to the 4 meter, what will be your normal stress? 48 megapascal. This is at which level? Embankment at 3 meter. So as your embankment is raised from 3 meter to the 4 meter, what will be normal stress at the bottommost point? So that is what we have to find out. As we are dealing with the effective parameters, we have to find out what will be your effective normal stress. So how can I find out this effective normal stress? This I can say that whatever the initial normal stress, let us say sigma n. So because of this construction of this embankment, or as the embankment level is raised from 3 meter to the 4 meter, what is the change in normal stress is occurred? That is what we have to find out. So what is the change in normal or change in effective stress? As the major stress, as it is of stable condition, we know that the major principal stress will be of vertical condition. So I am representing with delta sigma 1. As we are dealing with the effective values, so here I am taking with effective. So how can I find out delta sigma dash? That is what nothing but total stress minus pore water pressure. Right? So here we have to find out that what will be your, so here as I'm using the change, here also I will use that what will be my change in pore water. So here I have to find out what will be my total normal stress, and also I have to find out what will be my change in pore water pressure. But we already know what will be the change in normal stress. We know that directly. If it is raised from 3 to 7, what is the change in height? 4 meter. So what is the change in normal stress is occurred? 4 into what is the gamma value? 16. So how much it will be? It will be of around 64 kilopascal. Right? Now we know the change in normal stress, but what we have to find? We have to find the change in pore water pressure. How can I find the change in pore water pressure? That is from based on the Skempton's pore water pressure parameters. So if you remember the equation, how can I express it? The equation is nothing but a B into change in minor principal stress plus A into change in major principal stress minus change in minor principal stress. Just now we have found out this value is obtained to be around 64 kilopascal. Now, how can I find out the change in minor principal stress? Suppose if I take any element, if I know the major value, how can I find out the lateral earth pressure or minor principal stress? By using some constant. That is what lateral earth pressure coefficient. So if it is at rest, we will use that rest condition depending upon the corresponding criteria. Now look into the question. Now as of now they haven't mentioned anything. Now move on to the next. The dissipation of pore pressure. What are the assumptions we have to consider? The dissipation of pore pressure during this stage is negligible. So we should not consider any dissipation of the pore water pressure. That means water is not expelling. And what is the second condition? Lateral pressure at any point is half of the vertical pressure. So here this lateral pressure is directly given. Otherwise, they will give some constant. Depending on that, we can find out. So here, as they are directly given, how much we should consider the lateral pressure? That is what nothing but a measured by 2. They are asking us to consider half of this. What is the half of this value? 64 by 2. That is what nothing but 32. Now that's it. Find out the change in pore water pressure. That is what nothing but a B value. In the given, it is given as 0.9 into change in minor value 32 plus A value is mentioned as 0.5 times major 64 minor 30. So if you solve this, we will get this value as around 43.2 kilopascal. That's it. Now find out what will be your effective normal stress as the fill is raised from 3 meter to the 7 meter. Sigma 1, that is what be at the level of 3 meter 48 plus by the fill reach to the 7. What will be the change in normal stress? 64 minus. What is the change in pore water pressure? 43.2. That implies what will be the effective normal stress? That is what nothing but 68.8 kilopascal. That's it. What will be your shear strength? That will be equal to the cohesion. Effective cohesion is given as 50 kilopascal plus normal stress is obtained as 68.8 into tan of 5 dash is given it as around 21 degrees. So if we solve this, we'll get this as around 76.40 kilopascal. Right? Now, so as of now, we have discussed, I think, different types of problems by covering all the concepts. Okay, just depending upon the type of the test, understand that which parameter is going to be 0. Then your problematic will be easier. That is only the major part of the problem. I think as of now, we have covered all the different types of problems under the shear strength. And from the next video, we will start seeing the previous year GATE questions. Thank you.